Okay, another brief synopsis. Okay, said all this in a little more detail. I'm going to say it fast now because many people don't need all the detail. Linear transformation from one vector space to another is a rule that has the properties that when the transformation is applied to vector v1 plus v2, it's the same thing as if the transformation is applied to v1 and then separately to v2 and the two are added. Also, if the transformation is applied to c times some vector, where c is a constant, it's the same thing as if you applied the transformation to the vector and then multiplied by the constant. Now, two examples. We have transformation here, t of xy equals 3x plus 4y. Okay. We want to verify these properties. Well, I'm going to let x1, y1 stand for v1, x2, y2 for v2, and just plain old xy for v. And if I was to use a c, I'd just let it be c. Then I established t of v1 plus v2. Well, v1 plus v2, this plus this, gives us this very clearly. And then when t is applied to that, well, t does what? It takes the first number and multiplies it by 3, takes the second number, multiplies it by 4, and adds the 2. So we're going to get 3 times this, which is here, plus 4 times this, which is here. Well, this very easily rearranges to this, and the reason I rearranged it to this is that this is t of v1. Okay, apply the rule to the v1 vector. It's going to be 3 times the first coordinate plus 4 times the second. That's 3x1 plus 4y1. And when we apply t to v2, we get this. So we've established that t of v1 plus v2 equals t of v1 plus t of v2. I didn't bother to write out the t of cv, but you write out the details in a very similar manner. Using, xy for v and just plain old c for c, you evaluate this, then you evaluate t of v and multiply it by c, and soon it comes out the same thing. Okay, now here's one that turns out not to be linear. T of xy equals x times y, so that t of our v1 is x1, y1, t of our v2 is x2, y2, and of course v1 plus v2 is still x1 plus x2, y1 plus y2, so t of v1 plus v2 would be what? x1 plus x2 multiplied by y1 plus y2. Well, you expand that, you get 4 terms that you see here. Okay, but now this isn't crossed out, I made a careless circle here, but t of v1 plus t of v2 equals what? Well, t of v1 is x1, y1, t of v2 is x2, y2. Well, this doesn't equal this. So t of v1 is not equal, t of v1 plus t of v2 is not equal to t of v1 plus v2. The two are not equal right there. Transformation is not linear. Now you could also have done the t of cv equals c t of v. It's going to turn out in this case that no, t of cv is going to be c squared times t of v. And it's worth working that out because you want to start to get a feel for how to identify linearity and nonlinearity. Of course, ultimately you write it out very carefully. But if you get a feel for it, then you're not going to be thinking you need a linear function and make up something that's not. It just gives you a better grasp on the whole concept.